Hello and welcome to this Cossan tutorial, which is part of the Cossan training course on uncertainty quantification. This tutorial is about building a simple Bayesian network model using our BN toolbox in OpenCossan. My name is Diego Estrada Lugo and I'm a PhD student at the Institute for Risk and Uncertainty at the University of Liverpool, and I'm also part of the Cossan working group. During this video, we're going to explain how to import all the necessary packages before building our model. Then we are going to define the nodes, build the network and visualize it, and finally we are going to do predictions and diagnosis using the compute inference method. From our last tutorial, we know how to download and install the Bayesian Network toolbox of OpenCossan. In that video we showed how to install the development version of OpenCossan and all the submodules needed to build our Bayesian networks. Now we are going to show how to use that toolbox. So to build a Bayesian network or a Cradle network or an enhanced Bayesian network in OpenCossan, we first have to define the conditional probability tables of each of our nodes. Also, we have to define which are the parents of the node in the case that one node is a child. And also we have to define the name of the node. Once we have defined all the properties of all our nodes in our network, we proceed to construct our entire Bayesian network. In case we are using enhanced Bayesian network, we need first to reduce our enhanced Bayesian network and to leave it as a traditional Bayesian network. After doing that, we can either visualize the network or we can directly compute inference, so we can get our posterior probabilities to do our prognostic or diagnostic analysis. Okay, so now we go to Matlab. There are three things that you should check before starting building your models in OpenCossan. The first one I would say is that you need to make sure that the workspace is empty, so we don't have some extra nodes that will cause some errors in our model. Okay, the other thing is that we need to check that in our current folder in Matlab, we have only the directories that are necessary for our OpenCossan version that we're using. So we need to make sure that only these files are included in our path in Matlab. So as you can see here, I'm in the desktop and OpenCossan, and this is my current folder. To give an example for this, I have added in purpose another version of OpenCossan that is not the one that we want to use in this case. Okay, so what we have to do is select all the unwanted searching paths that corresponds to our other OpenCossan versions, and then we just remove them from the search path. Okay, and then we just end up with the Matlab searching paths. Okay, we just don't touch those, so we just save it and close. The third thing we need to check before building our models in OpenCossan is we need to check, we go to apps and then we go to check that we have installed the computational biology toolbox in Matlab. If you don't have it, you can click in get more apps and then follow the instructions to install that toolbox. Okay, so now we can start building our Bayesian network. So I'm going to open a new script, and then I'm just going to name it tutorial Bayesian Network in OpenCossan. Okay. So the first things we are going to do is we have to import all the required packages that we're going to need. So we need to import the Bayesian Network toolbox. So we type import opencossan.base Bayesian networks and then Bayesian network. Okay. And then we need to import the type of nodes that we need for our Bayesian network. In this case, we are building a traditional Bayesian network, so we need to import the discrete nodes. Okay, and then we need to add to the path the BN, the base toolbox for Matlab that we need to compute inference. So we do OpenCossan and then get instance. Okay, and with that we initialize OpenCossan and add our BNT toolbox to our path. Okay, and then we initialize our network, and it's going to be our counter for the networks. Now, in another video, we showed an example of how to build Bayesian networks. So I'm just going to open it as this one. So we want to build this this network in this example. So we need to do it like this. Okay, I'm just going to split this screen. Okay, so our first node that we want to build is Cloudy, that has states. State 1 is true, and state 2 is false. Okay, and then we need to add 1 to our counter. Oops. Okay, and then, as I showed you before, we need to define our conditional probability tables. So we need to do that, we need to create a cell. In this case, because this is a root node, it's going to be a cell of 1 by 2, where 2 is the number of states of our node Cloudy. If Cloudy has 3 or 4 states, it will have 3 or 4 in this dimension. Okay, and then we need to enter the probabilities in this cell. So cloudy. So we need to access our cell. Personally, I like to access this way the cell. So here I have it's better for me to visualize the number of states that my node has. You can do it in other ways, but personally this is the easiest way to visualize our states of the node. Okay, so this one has when cloudy is true is the probability is 0.8, and the probability of cloudy being false is 0.2. Okay, and then we create our node. We are going to create a variable called nodes, in which in this entry n we are going to create our discrete node, and we pass the properties inside this discrete node. So the minimum required properties are the name and the CPT and the parents when they're needed. Okay. So the name of this node, I'm just going to call it cloudy, and then we need to say where is our CPT distribution or conditional probability distribution. In this case, we saved it in our cell called CPT cloudy. Okay, and because this node has no parents, we just leave it like that. Okay, we don't need to pass the property parents in this node. Okay, and then we create another node called rain, where the state 1 is true and the state 2 is false. I like to create these comments here so I can know to which state each of the entries in my cell corresponds to. Okay, so I'm just going to do it like this, and then remember we have to add 1 to our counter, and then we create our cell that in this case is going to be called CPD rain, and then we create a cell. In this case, rain is a child of cloudy. Okay, so first we have to put the number of states of our parent. In this case, it's going to be 2 because this is the number of states of cloudy, and then 2 because this is the number of states of rain. Okay. Remember that we have to follow this structure. First, the number of states of the parents. In case this node has 5 parents, we have to put first the 5 states of each of the parents, and then at the end we put the number of states of the node that we are defining. Okay, so this is the way we define the dimensions of our cell. Okay, and then we put inside the probabilities for this. The probabilities for this node. Okay, so I'm just going to do 1 and 2 because this is the number of states of rain, and 1 is because we are going to enter first the state 1 of cloudy. Okay, so when cloudy is true and the probabilities of rain being true is 0.85, and then the probability of rain being false is 0.15. You can notice here that these two have to sum up to 1. Okay? And then we do the same for the case when cloudy is false. So the state number 2. In this case, when cloudy is false, the rain is a very low probability of having rain. Okay? Okay. And then once we have defined our CPT, we need to create the nodes. So we're going to add it to our variable called nodes that is going to be read by the function Bayesian Network. And this is going to be a discrete node with name the name is rain. And then the CPD is going to be CPD rain. In this case, rain is a child node, so we need to specify which are the parents of this node. So we need to pass the property parents, even though this one has only one parent, we need still to call the property for the property parents. Okay, so the parent is going to be cloudy. Note that this has to be a string, and the name has to be exactly as we define it in our node cloudy. Okay. Then our next node is sprinkler. So we just create sprinkler with states 1 is true, state 2 is false. Okay. Again, we add 1 to our counter, and then we create the cell for sprinkler. Again, this is a child node, so and the parent has two states. So we just type the 2 states of cloudy and the 2 states of sprinkler. And then CPD, we need to populate our cell with the probabilities in our probability distribution and our probability tables. Okay, so we need to access when cloudy is true, and then the two states of sprinkler, which is going to be 1 and 2. You have to note that these probability distributions, these probability values can come from any expert knowledge or historical records. So, for example, cloudy, the probability of being cloudy can come from analyzing the meteorological records depending on where we are. So, for example, I'm assuming here that we are in England, where most of the time is raining. So that's why I'm just using this probability distribution. But if we are, for example, in the desert, probably the prior probabilities are going to be different, right? It's going to be maybe 0.1, and then the probability of being cloudy is going to be 0.9, for example, right? So just to clarify that these probabilities have to be calculated beforehand. Okay, so then we add our probabilities when cloudy is false for the 2 states of sprinkler, and then we just need to define our node which is going to be stored in the nodes variable. Okay, so then we pass the properties, which is the name. In this case, it's going to be sprinkler, and then the CPD is going to be CPD sprinkler. Probably I'm going to have some mistakes in the spelling, but that's going to be something that we're going to do later on. Matlab is going to tell us if there is an error. Okay. And then we need to define our last node, which is wet grass, which has state 1 true and state 2 corresponds to wet grass being false. We add 1 to our counter. We create our cell. In this case, it's going to be wet grass. I'm just going to leave it lowercase, okay? And then cell. Okay, here's wet grass has 2 parents, right? So we need to define our cell in the terms of these 2 parents. Okay, so first we define our node rain, which has 2 states. So we add 2, and then sprinkler has 2 states, and then wet grass has again 2 states. Okay, so our cell is a cell of 2 by 2 by 2. Okay, so we need to populate this cell. So we need to put the probabilities when sprinkler and rain, from when rain and sprinkler are true for the 2 states of wet grass. So in this case, it's going to be 0.99, and the complement is going to be 0.01. And then we want to enter the probability when rain is false. So rain is false. I'm just going to do it like this. So because this is our first node, actually it could be nice just to tell what is our order. So we are first refining rain, and then is sprinkler, and then it's wet grass. So we have an order of the states. Okay, so when rain is false, the probabilities of wet grass are 0.9 for true and 0.1. Okay, now when rain is true but sprinkler is false, the probabilities are the same, as we can see in this example. Okay, and then the probabilities when the 2 of the parents are false, it's going to be 0, 0, 1, 0, 1. Okay, again, this probability could have been 0, but is not common to use a 0 for a state in a Bayesian network, unless we are completely sure that this state is going to never happen. Okay, that's just a common practice in Bayesian network. So because, for example, let's say that there was no rain and the sprinkler never got activated, but maybe the grass got wet because I don't know, someone poured a bucket of water on the grass. So even though it's very unlikely in our model, this can happen, and then we are leaving the option open for that event to happen. Okay, it's just the way to model in Bayesian networks. So we need to define our node here. So oops. So here our node is called wet grass, and then the CPD is CPD wet grass, and then the parents. Okay. Okay, the parents, since we have more than one parent, we have to put them in an array which has strings as. So first we define rain. That's the order that we're giving here. So that's the way we define here. And then we are using sprinkler. Okay. So our next string is going to be sprinkler here. Remember, they have to be spelled exactly the same as they were defined originally. Okay. Otherwise, you will have some errors when you want to run your model. Okay, so all the nodes are defined. So the next step is we need to build our network. So we build our net. We call it wet grass net, and then we call our Bayesian network method, which needs the variable nodes. That's a property that's needed for this method. And with that, we build our network, and then let's say that we want to visualize it. So we want to visualize it. So we do that with the makeGraph method. So we need to call our variable storing our Bayesian network, and then we access the method makeGraph. Okay. So I'm going to run it. Hopefully I didn't get any spelling mistakes, or I can check. OpenCossan is going to tell me if I did something wrong. Okay, so here we are. First we need to save our script, so I'm just going to save it in the same directory. So we want to call it wetgrass net. Okay, so it's processing. Oh, okay, so I need to change then. Just doing some illegal stuff in Matlab. So I'm just gonna call it tutorial. Let's try again. Okay, it's initializing OpenCossan. Okay, so here's our network, and you can see it's pretty similar to the one that we had in our example. Okay, so the next step is to compute our analysis. So in the example, first we wanted to compute the probability of the grass being wet. Okay, so we're going to do inference with Bayesian networks. So we want to wet grass true. We want to create our variable that is going to store the result, and then what we want to do is access the variable that is contained in the network, and then call for the method compute bn inference. Okay, this is important. It has to be compute bn inference, because another methods in OpenCossan allows you to compute inference in another type of Bayesian networks, like enhanced Bayesian network or Credal networks. Okay, so just to let you know. Okay, and then we compute the marginal probability of wet grass. Wet grass was called like this, so I'm just going to copy and paste it so I don't do any spelling mistakes. We continue in our next line, and then in this case we are going to use the built-in toolbox to compute inference. So we're not going to use this submodule that I showed you how to download in the last tutorial. First, we're going to do this with the built-in toolbox algorithm, and then we just need to say which algorithm we are going to use. Currently, the algorithm included in available in OpenCossan is variable elimination, which is one of the most common algorithms for inference in Bayesian networks. So we're just going to use that. Okay. All right. So I think this is all what we need. So we just select. We don't need to run again the whole code. We just run this part. So we right click on the selection and then just evaluate selection or F9. Okay, now is OpenCossan is computing inference. Okay, it finished. So in the command window, okay, what we do is just type the variable that we define to compute inference, and then we type dot and then the key tab, and then we can access to all the properties of this variable: the description, the evidence, the information, joint probability, and marginal probability. So just to show you what you can do. The description, well, we didn't add any descriptions, but if we had added a description, let's say, so we put description our first inference, okay, and then we run again, just to show you. Oh, okay, an error. Okay, let me do this and try, I don't know if Well, it's not like that. Well, you know what? I'm just going to run it as it was previously. Okay. Okay. What is important here is that we want to access the marginal probability. This is the one that is going to tell us the posterior probabilities. Okay. So as we can see here, the state 1 of wet grass is 0.7023. And if we check in our example, this is what we're expecting, okay? And then this is just the complement, which is going to be the probability of wet grass being false. Okay, as I show you, it's handy to have labeled to which state correspond to each of the states in the node. Okay, so we have labels of each of the states in the node, in our posterior probability of the node. Okay, so now we are going to do that. The second exercise. So when we add evidence, okay, so we are going to do a prognostic analysis. Okay, so sorry, a diagnostic analysis. Here we did we predicted what was the probability of the grass being wet, and now we want to see what is the probability of cloudy, that it was cloudy, given that we know that the grass was wet. Okay, so what we do now is going to be cloudy wet grass. Okay, and then again we access our network. We use again our compute PN inference method. So we want to know the marginal probability of cloudy, in this case cloudy. Okay, just to make sure that it's written the same. Okay, now now we need to put use BNT. We're just going to use the built-in toolbox, and then here we need to also include which node we observed. Okay, so observed node. The observed node was wet grass. Okay, and then which state we observed. So we say that with evidence. So we need to say which state. So we observed that wet grass was true. So true corresponds to state 1. Okay, so we just have to type 1 here. And then we have to pass the algorithm that we want to use. In this case, is a variable elimination. Okay, and hopefully it's all right. So I'm just going to evaluate this section. Okay, all done. And then We just want to see the marginal probability. Okay, and here is telling us that the probability that it was cloudy, given that we observed that the grass was wet, was of 89,567. And we just comparing now from our example for our sample. Okay, so this is the expected result. Okay, so um, so this is it. Um, I hope. I think. Yeah. Okay. So to summarize, in this tutorial, we have initialized our Bayesian Network toolbox for OpenCossan. We built a very simple model in OpenCossan, and then we make some predictions and some diagnosis. In our next videos, we're going to show another functions of the Bayesian Network toolbox in OpenCossan. And as always, if you have some problems launching the Bayesian Network Toolbox, you can contact us in our email address, contact at cossan.co.uk, or to my personal email address. Happy Cossaning!